All right. Morning, everybody. Welcome to the Wednesday plenary. Yes, it's cold in here. It, it does take time. The hotel is responding to every request. It's just taking time to figure out what settings they can set it to that actually makes it feel comfortable. So they're doing another boost of the temperature, and we should be feeling the effects in about 30 minutes as you all come in here to help us warm up and as the air conditioning system responds to the latest changes. So keep the complaints coming in and we'll keep raising the temperature until we all feel good. Okay. Today, Wednesday plenary, it's the reports from the LSSD Science Collaborations Day. We're going to start with the usual reminders that we have a code of conduct, and if you experience or witness any violations to the code of conduct, please get in touch with our code of conduct contacts. Reminder also to keep an eye out for the stickers on name badges that indicate people's comfort level with contact. The lost and found is the RCW registration desk, and keep an eye out for those social batteries. And remember that the copper is the quiet room if you do need a moment to just have a sit. For everyone who's on Zoom, please stay muted unless you're speaking. And as always, in every room, in every breakout session today, speak into the microphones so that the virtual participants can hear you. Today's special event is the unconference. I noticed right away people really took to the unconference board this year. You get it. I think just having done the unconference for so many years, there was a bunch of ideas right from the start. Lots of voting is happening, so that's great. I don't know that there's room for more new ideas on the board, but try to get them on there. Go and take a look at the ideas that people have proposed. Use the markers to vote for the sessions that you like. The deadline for voting is 15 minutes before the end of lunch today, because that's when I'm going to go to the board, tally up the votes, and the 3 sessions that have the top number of votes will get assigned to one of the 3 breakout rooms. I'm going to post the results in Slack and on the conference webpage, so on the session webpage for the unconference. The unconference is in person only. There's no Zoom component for the unconference because usually these are very unstructured, no presentation. You show up in the room, you start talking to each other. It's very interactive. You go into breakout groups and you co-work together. That kind of thing doesn't do well with virtual. So there is no Zoom room for the unconference today. And when you do arrive in the room, yeah, just start engaging with the other people who came to talk about the same topic as you. If you were the one who proposed the idea, it's great if you can sort of take charge in the room, lead the discussion, that kind of thing. So go have a great time. All right, now I'd like us all to welcome Gotham to the stage. He's going to be leading us through today's presentations.
Hi folks, my name is Gautam Narayan. I am the Rubin Science Collaboration Coordinator standing in for Will Clarkson over the last year. And I'm delighted to sort of introduce all of the Rubin Science Collaborations. There are 8 of these LSSD Science Collaborations. This is an independent and worldwide community of scientists that are really organized based off of different research themes. They are supported by the LSSD Discovery Alliance, and they're always welcoming to new members. Now, at this point, I want to make one quick statement. I am trained as a cosmologist, and so I have to care about selection functions a lot. All of us here are selected to be here and are all excited about Rubin science. But there are a lot of people who could not make it here because they were worried about traveling to Arizona or to the US, or worried about travel at all with the current federal funding situation, given the costs for childcare, for flights. And there are many others who simply have not been able to join us here at RCW. All the same, these people are all part of the science community and welcome in the science collaborations and are critical if we are to do science with Rubin, of course, but more so, we value them not just as scientists, but also as our colleagues and our friends. So the science collaboration. The science collaborations really advise Rubin project on the scientific decisions, including things like the survey cadence. They are united by the Science Collaboration Federation Charter, which is linked over there. The collaborations, like I said, belongs to you. There are 8 of these groups. Several of these folks are in the room. AGN is led by Matthew Temple and Neil Brandt. This is the Dark Energy Science Collaboration, and you'll hear an update from Renee Hlozek. the Galaxy Science Collaboration from Sugata and Simona May, the Information and Statistics Science Collaboration from Ashley Villar and Francois Lenus. But those two co-chairs are both going to be rotating off, and so there is an ongoing election. Should you wish to be in charge of a science collaboration, now is your chance. The Solar System Science Collaboration has Meg Schwamm and Colin Chandler, both of whom are here. Stars, Milky Way, and Local Volume has Peregrine McGee, Kirsten Dage in Australia, and Tom Wilson, who is here. Strong Lensing has Simon Birer, who's online, Anuprita More, and I want to add that Crescencio Tortora will be joining starting tomorrow, August. And Transients and Variable Science finally from Igor Andrioni and Sara Bonito. So there are over 2,500 members now in the science collaboration. There's no membership fee to join. There's no institutional affiliation requirements, but data rights may be tied to institutions as part of the in-kind contribution program. Any institute can propose an in-kind contribution, of course. There are also no requirements on time or exactly what you contribute as part of a basic membership, though higher levels of membership can often come with a time commitment requirement. With that, we're going to give each of the science collaborations a few minutes to do a highlight. They've only got 6 minutes each, so please hold your questions until the end or ask them in the Slack channel link there. We'll start with AGN, which is, I believe, online.
Yes, can you hear me okay?
Yes, we can.
Very good, thank you. Yes, so I will today give a brief update on the activities of the AGN Science Collaboration. As part of this collaboration, we aim to study the accretion physics onto supermassive black holes. We aim to study supermassive black hole demographics throughout the universe, and we want to study supermassive black hole galaxy connections. And we have multiple projects in each of those broad areas. From this information over on the right, we currently have about 250 members. We continue to grow rapidly. We grew 21% just over the past year. And then this table shown gives the numbers of people in each of the 6 largest national memberships, so you can see we're widely geographically distributed. Next slide, please. Yeah, so this plot basically shows the overall organization of the science collaboration. As mentioned, the co-chairs are Matthew Temple and myself. We have a number of working panels that keep the science collaboration running. And then we have a number of scientific subgroups that are advancing, various critical science areas. We also have a liaison to the critical survey cadence optimization committee, and we've had multiple interactions with them. That's obviously very important for the AGNs. And then we have other important representatives as well as task forces. Next slide, please. Yes, so one point I will make is we've managed to have actual annual in-person meetings for the past several years, which has been very positive. This photo here is from our most recent meeting, which was just held earlier this month in Durham, UK. It was organized by Matthew Temple, was the lead organizer. And at this meeting, we had extensive discussion of the various ongoing science projects that we aim to execute. And we had at this meeting, 32 talks, tutorials, working with the Rubin data, hackathons, where we sort of get our hands dirty with things, and planning discussions to actually execute science projects. Next slide, please. Yes, and if you have more interest in exactly what we're up to, we actually have put most of our meeting recordings on YouTube. In fact, we now have more than 75 hours of our meeting recordings on YouTube. The link is given at the bottom, and so you can enjoy what we're up to in as much detail as you desire. It's all pretty well organized there for you. Next slide. Yes, and so one place where the AGN Science Collaboration, I think, has been a leader, and this makes sense given the multi-wavelength nature of AGNs, has been in gathering multi-wavelength data to facilitate AGN studies. For example, in the deep drilling fields, we have led the gathering of substantial amounts of data with XMM Newton, where we now have 10,200 X-ray selected AGNs in the deep drilling fields, as well as even more from Cosmos and so on. And then we also, led by Mark Lacey, have gathered extensive Spitzer data in the deep drilling fields. And all of this will be very important for AGN selection and characterization. Next slide, please. Yes, and we have done a lot of additional work beyond that previous slide in selecting AGNs. We have utilized SED fitting, shown over on the left, which also provides very useful measurements of galaxy stellar masses and star formation rates. And then over on the right, we've also done a radio AGN selection, and we've performed optical variability AGN selection. So we have pretty good AGN samples already ready to go, which we can use to calibrate Rubin's straight AGN selection. Next slide. Yes, and so a number of other things we're up to. We have, as I mentioned, effective AGN variability science in the deep drilling fields requires a well-designed cadence. We've provided much feedback to the Survey Cadence Optimization Committee in this regard. The ocean strategy, as we've discussed with the SCOC, helps to resolve many of the earlier concerns that we have, although I will note that there still are some unresolved issues and necessary further discussions on the filter balance, on the depths of the dense sampling epochs, especially out in the redder bands, and on the timing that the deep seasons will have for the various deep drilling fields. We have interests in all of those and would like to continue active discussions on those points. Next slide, please. Yes, we also have ongoing in-kind contributions, 5 European and 1 Canadian. These involve gathering precursor data, looking at periodic supermassive black hole behavior, looking at reverberation mapping, refining photometric redshifts, things of that type. And so those are very important contributions. Next slide. Yes, and a number of other things. We're clearly, working on the early data. We've updated our charter and publication organization documents. We are coordinating with other critical AGN projects, such as spectroscopic reverberation mapping campaigns, which are also ongoing in the deep drilling fields, as well as general spectroscopic follow-up programs. And we have a number of other activities, ongoing census, the Rubin Euclid-derived data products group, and so on. Next slide. Yes, and so then just to wrap up, I will also mention that we're also very interested in and involved in outreach activities. We've given worldwide AGN talks to sort of show people the possibilities of AGN science with Rubin. We run a number of teacher workshops. Our Serbian colleagues have run useful workshops for students from Ethiopia and Serbia. And next slide. And so I will also just end by mentioning that unfortunately I can't be there this year, even though I'd like to be. And that's because, in fact, this week I'm running one of the teacher workshops here in Pennsylvania. And this photograph taken this morning shows some of the high school teachers attending the workshop this year. And you can see they're actually working on their Rubin activities. And so they can take this information back to high school students as well. So thank you.
Very cool. And Renee Mausek next will be presenting for the Dark Energy Science Collaboration.
Thank you so much. I'd like to start by saying we do not have a playlist, but if supermassive black hole is not on the AGN playlist, I will be very upset. So for those who don't know me, my name is Renee Hlajek, and as Gautam said, I am the spokesperson for the Dark Energy Science Collaboration. I lead this group with Tessa Jaltema, who couldn't be here in person. We have a huge and vibrant collaboration. This was taken last week at our collaboration meeting at beautiful Urbana-Champaign, and you can see we had almost 300 people, some remote and many in person. So we are using Rubin data with a bunch of different key probes, including gravitational lensing, supernovae for cosmology, clusters, and we combine a lot of technical computing and analysis expertise to do those science and to build those pipelines. We have a science overview document that describes some of our working groups and our structure, and also gives you some insight into how you can join. So we always welcome new members. We have over 1,300 of those. And in fact, we have about 240 full voting members of the collaboration who pick new spokespeople like Gautam, who is going to replace me very soon. One of the things we're most proud of is that a lot of desk members have been involved in commissioning for Rubin. You can see some of these publications here, these technical notes of the teams that were involved in a range of different activities. We're really, really proud of Rubin, and we really are excited to be involved in that way. And we hope that we can continue to be involved in really processing and analyzing and giving insights into the data. We also have been building infrastructure and getting ready for some early science. So a couple of things that you see here. First of all, we are developing the FastDB alert database, which will enable folks to access and also cross-match and do interesting science with the alerts. Particularly here, you can see we have a light curve. This is a combination of ComCam and DECam light curve taken, which is very, very exciting and sort of hot off the press. We're also interfacing with a bunch of other surveys, ground-based surveys that will provide complementary data to enable us to understand the physics of these objects and to use them for cosmology, including gravitational wave alerts as well for dark siren studies. One thing that I put in bold here is that we really are keen to collaborate with other science collaborations. DESC really has a lot of synergies with all of you, and we'd love to talk more in this meeting and ongoing. I must also highlight the weak lensing study of Abel 360. This is from commissioning data led by Anja van der Linden, who's here. Speak to her about this amazing result. We're testing our pipelines, multiple different pipelines, to get the weak lensing signal, involving a lot of junior members. And it's really, really fun just to see this exciting science coming from very early data. We're also testing pipelines on the Euclid Deep Field South. And if you haven't heard me plug Cosmos enough at this meeting, I just wanted to say this will be even better with Cosmos. We're testing our pipelines using the rail infrastructure to compare different codes for estimating photo-Zs, and then also look at the impact of what those photometric redshift uncertainties will have on our cosmology pipelines. You can see there's a note here. There's also a great paper by the rail team on the algorithm itself. We're very excited about DP1 and early science. The main cosmology results will come from previously known as DR2, now affectionately known as DR1, the first full year of data, but we really need to test all of those pipelines, and we're getting ready for that with DP1 and 2. Particularly, we are thinking of science papers that we can write, including testing template production, building catalogs of strongly lensed sources, photometric redshift calibration, synthetic source injection, the list goes on and on. We've spent a lot of time getting feedback from the collaboration about what science papers they're interested in, and then thinking how we can enable that with the time remaining. So there's a lot of fun stuff to do. And if you're excited, please come and speak to me. We really want you to join. Okay, that's me.
Hi, good morning. I'm Simona May. I'm one of the two co-chairs of the Galaxies Science Collaboration. So we are around 350 members. And if you're interested to know more about us, there you have the webpage of the collaboration. So what are we interested in galaxy formation and evolution? And Rubin, we really have a strong impact in our field of research in terms of statistical galaxies up to the very faintest galaxies. And for the search of low sulfur brightness features around galaxies, tidal tails, merger remnants, that will really bring us a breakthrough in the field. So this is very important for us. Connection between galaxy properties and the dark matter halos and galaxy cluster, intercluster medium. So this is our organization, and you can find it on our webpage. We also have working groups that are shared with other collaboration, like the Star Cluster Working Group. Some highlights from what we have done of our recent activity. So low sulfur brightness science is very important for the study of galaxy formation and evolution. And the main challenge is to identify the most critical LSB feature that will constrain the theoretical models. Here you have an example of what LSST will do and what we have seen in the science validation. And there is a very large effort to make consistent measurements in observation and simulations. So for what concerns the recent data processing, we have been collaborating with data management to produce the wonderful images you have seen on the first look. So that are images of the Virgo cluster. And they were created with the LSB optimization philosophy in mind. So not aggressive sky subtraction, but a sky subtraction that preserves the low sulfur brightness features. So we expect that the default pipeline should also produce similar images as an output so that we can study these important features for galaxy formation evolution. So we need the images with dedicated sky subtraction, and I received a lot of feedback in the last days. Please release the science the SV Virgo cluster image as soon as possible, because they're very important for us to have a breakthrough in this field of research. This is what we are speaking about. You have seen these images at first look, and here you can see the very faint low sulfur brightness features that are, for example, on the top right, that are the signature of mergers between galaxies, and they give us a very strong insight in galaxy formation and evolution. You will find all the information on the website. We have 3 sessions starting from today and to tomorrow. So if you're interested in our science, please join us. And we accept members also without data rights. And please look at the webpage and join if you are interested in this. Thank you very much. Oh, sorry, I forgot to speak about galaxy formology. One sec. Sorry. And another important, I will go very fast. Another important, a very important field of research is to characterize the morphology of galaxies. And for this, we have in-kind contribution from the Italian INAF team that you will see here, so that they build convolutional neural, I'm forgetting the Italians, I'm really sorry about that. Structural parameters with machine learning. So they have developed dedicated simulations and train the network on these simulations. And right now, GalNet is running on the R-band DP ComCam data applied to the mock test, and is ongoing, and we will have soon a new galaxy morphological classification. Thank you very much.
Good morning. Next slide. Thank you. Hi, and good morning. My name is Peregrine McGee. I'm one of the 3 co-chairs for the STARS, Milky Way, and Local Volume collaboration. STARS, because we're looking at resolved stellar populations. Milky Way, because we're looking at the structure and evolution of our home galaxy. And Local Volume, we're exploiting Rubin Observatory's ability to detect and characterize resolved stellar populations out to a considerable distance. And so all that together, in a nutshell, we are supporting one of the 4 key science goals for LSST, which is mapping the Milky Way. So we have 3 co-chairs, myself at SLAC National Accelerator Laboratory here in California, Kirsten Doug, who's in Western Australia at Curtin, and Tom Wilson, who's actually here in the audience from University of Exeter. So we are spread across the entire globe. So next slide. We are organized into 7 different science working groups working on a number of topics. Stellar neighborhood is looking at primarily very low mass stars and brown dwarfs, including like low metallicity, ultra cool members of the halo population. We have work on open and globular star clusters, variable stars, which of course has a lot of connections with the translated variable stars collaboration. A 4th working group on galactic bulge. I'm a lead on the galactic structure and interstellar medium working group. And then we also have Magellanic Clouds, which is not only looking at our 2 major satellite galaxies that are visible in the southern hemisphere, but also other dwarf galaxies and other members throughout the local volume. And lastly, we have near field cosmology. So that's has a lot of tie-ins with what you would see with dark matter, for example, and how that influences the structure and evolution of the local volume in our own galaxy. Next slide, please. So a few things that I want to talk about the Rubin Early Science Program. Obviously, we're working with resolved stellar populations. And where do you find most of the stars? In the crowded fields, in the disk of the Milky Way along the galactic plane, in globular clusters, and understanding how the LSST data reduction pipeline and photometry and astrometry work in these crowded field conditions is a critical point for galactic science. As you can see, the globular cluster 47 Tucana. Once you get into the crowded field, the pipeline essentially can't resolve the individual stars. Also, in the current science validation observations, which do cover a range of high to mid to low latitude galactic latitude fields. When it comes into the lowest galactic latitude fields, you see there on the lower right, that's basically galactic center, the galactic bulge. And so we very, very quickly go from a not very crowded stellar field to one that's very, very dense. So there's not a whole lot of sort of intermediate stellar densities in that field. Okay, next slide, please. And we have a number of ongoing and also to be started very soon primary in-kind contribution teams. 3 from Italy and 1 from Mexico, everything from looking at the measure of optical fluxes from the diffuse ISM to looking at stellar populations and then general software pipeline development. And one more slide. Where to find us? We have a website, rubensmwlv.github.io. Our main Slack channel on the LCC Discovery Alliance workspace is hashtag Milky Way. We're doing our email list management through Google Groups, and there's a link there. Our full collaboration meetings right now are being held monthly. We're alternating between 8 a.m. and 7 p.m. Pacific time because we have obviously active members both in the US and in Europe, but also in the Asia Pacific. We have sort of cross connections with other teams, obviously working on crowded field photometry, I think, which is also an issue with the variable stars component of TVS. In common with desk dark matter, we're very interested in detection of stellar streams in the galactic halo. And also in common with galaxies, we're interested in low surface brightness structures, not only around local volume galactic members, but also in general looking at the extended diffuse emission from the interstellar medium. And here is a breakdown of our membership. As of a week ago, we had nearly 260 members. And this shows you the distribution across our 7 working groups, variable stars, actually star clusters, variable stars and near field cosmology being the most popular ones. And that's what I have. And thank you very much.
Thanks, Peregrine. Next, we'll hear from Meg Schwarm for the Solar System Science Collaboration. Meg.
All right, the task to be super excited about solar system and get you all the information in 6 minutes, but I'm going to do my best. So the Solar System Science Collaboration is 260 members around the world. We are broken into working groups based on populations and also building software. My partner in crime and everything within the collaboration includes co-chair Colin Orion Chandler, who's our co-chair from University of Washington. But I want to really highlight, although I'm the front-facing person and often sometimes the loudest, it is these people all together that really are driving the Solar System Science Collaboration forward. So I really want to talk about what I couldn't do last year, or we couldn't do as a community, I think, is really show how much work has been happening over the years. And just, I think this slide is to wham you with a bunch of QR codes to highlight all of the preparatory work that's been happening that's turned into papers. So software that's being released as a community software, proposals for new observations, studying and making predictions for LSST, solar system discovery yields. And I think it's really incredible to see just, this is from all papers I've taken in just the last year. So I really want to highlight that the ramp up we can really see happening now, that people are starting to predict and getting tools, community tools ready that are already production grade, right, that the community can use. So you can download this on the slide from the slides to get all the QR codes, but I want to highlight that I couldn't fit all of them. This was just a subset that I could grab. And I think that's the exciting thing of how much early science prep is moving forward. And just this is what we have now. There's just gonna be so much more as we get towards and through into the start of operations. So one of the things that I want to get out of this week is that is understanding the sort of problem that we've been having and the things that we've been thinking about. And one of them over the past year has been evaluating the year one incremental templates and what are the implications for early science. What we're finding is that if we look at the math metrics, and on one side, on the furthest side, we're showing the math metrics for discovery of faint solar system objects within the wide fast deep. And then when you go to the northern ecliptic spur, makes sense when it drops significantly. And math is just an indicator when we actually look at the fields and what would have templates built and then be able to find moving objects, it's almost nothing. And so what we find and fear is that we won't have moving objects in the northern ecliptic spur. And if you plot that on an air mass plot of the peak of the northern ecliptic, it is literally what is up in the middle of the night at the start of operations. So the math metrics do not improve even with the new SCOC simulations, which are trying to push observations into the NES. It's just not enough. It's big enough area and it doesn't have enough visits to begin with. We put the minimum that was needed for our science. So what else can we do to enable solar system discovery above a declination of 0 in the first year? So that's a question I would hope we can have some discussions on, or if there are things that we can do. That's the thing that we're interested in discussing further of what can we do to boost and really get and enable solar system real-time discoveries in the first year in the northern ecliptic spur. I also want to highlight, we have 2 focus issues. We have one on solar system predictions and one on community software that are open for the first year and beyond to, again, coordinate, being able to easily find these resources. So thanks to AAS Publishing for being able to help enable this. Also, I want to just highlight one of the activities that are going on in the collaboration. Matt Holman, who is the PI of the layup software initiative, got a link framework incubator that has really facilitated being able to fit orbits at scale for LSST. It's been a problem that we don't know how we're going to fit the orbits at the scale for data releases. And so layup has sort of enabled this thanks to link frameworks, being able to optimize and bring this code really to life. So it's really exciting that this has happened over the past 6 months. I also want to highlight sort of the extraordinary and also I think really highlight how the community in solar system is ready to go, and that the interstellar object 3A Atlas happened to land, like no joke, we've joked about it, in the science validation survey observations and was serendipitously observed by Ruben. You could not have written it better. And so again, a big thank you to the Ruben commissioning team, the operations team, the construction project team, because this became a joint Ruben Solar System Science Collaboration paper, and it has also just been submitted. It is the first LSST CAM science paper. And so it's just a precursor of this. And so it was just amazing to see what we're going to get. It's just a taster. And so if you want to know more, come to Colin Chandler's talk. It will be in the solar system session tomorrow to hear all about it, and also read it on archive. But I think it's really exciting to see how many people we were herding over 150 people within the collaboration over a very short period of time to help dive in and help interpret the results and what was being seen. So really a testament, I think, to how ready our community is to dive into prompt products. So it leads me to my next point to show you the scariness of the fact that if we run our simulation from Circa that predicts what we'll find in the first year, so a little bit or a chunk more than that for LSST, we're going to get into about 3 million solar system objects are redetected and observed, most of these new discoveries. And so we get all of the solar system objects and 70% of them for the main populations in the first 2 years of the survey. We're going to follow them up and get lots more data that gives us better, precise things, but it is going to be a whirlwind in the first few years. And so there's so much high impact science. I just want to reiterate, we're going to be able to do with prompt products. And that is really exciting. And so when prompt products are flowing, this is the stuff we're going to be able to see immediately. And so that's going to be really amazing because there's going to be so much key science just from that data and just in the photometric and astronomical observations, even before we even think about images. So we have research notes that sort of highlight what those opportunities are, but just to highlight if you're interested in solar system science, now's the time to get involved. It's going to be such a ride over the first few years of LSST. Also, I just want to highlight, as I'm going to get kicked off stage in a minute, but just say that we've gone from organizing solar system readiness sprints to organizing solar system first data science sprints. And so we're going to be, if you're interested, come to Belfast in February. We're going to be working with the prompt products data, what things have been submitted to the Minor Planet Center, and then also later in the year, go to Seattle to do it all over. So come join us. It's going to be a wild ride. And it's really an exciting time to be doing solar system science and all science with Ruben.
Thank you, Meg. Next, we'll hear from the Strong Lensing Science Collaboration from Simon Bitter, who's online. Simon?
Yes, next slide, yes. Anuprita Mori, my co-chair, is in the audience, and this is kind of like my farewell.
If you're talking, Simon, we cannot hear you.
Oh, apologies, can you hear me?
Yes, we can now.
Yes, okay, thank you very much, Gautam. So this is my effectively farewell speak as the co-chair. I hand over 1st of September to Crescenzo Trotta. Anuprita Mori, my co-chair, is in the audience. And so the Strong Lensing Science Collaboration has a really wide range of science interests, from cosmology, cosmography, dark matter halos, microlensing, gravitational telescopes, so finding the earliest galaxies, to any physics involved in explosive transient when we can see it multiple times, and taking the really early, catching them very early, to galaxy formation evolution that we can probe through spiral galaxies and elliptical galaxies, any deflectors in any mass range, from clusters down to dwarfed scales. Next slide, please. Here are some activities, and linked are some of the Slack channels that we're using. We have a strong lensing simulation pipeline development, a lot of software development going on that's now started being used and applied to real data. We have two challenges going on. One is on static lenses and the other on transient searches. We have a slide on those. We are thinking of candidate central database. How do we catch those? How we can catalog them, etc. A lot's also going on in difference imaging analysis. What is special for strong lensing in a very crowded field, and follow-up coordination for many things. And also here to highlight, there's a cosmology forecast team, and most of those that's being listed here is in really strong or very close collaboration in DESC, in the strong lensing topical team and other working groups. So it is a really joint effort. Also to highlight, yes, thank you. So here just as an examples on the right, you see a ComCam image and a Euclid image, and we really want to bring the global strong lensing people together when it comes to exploiting transients in the LSST data. And so we have set up, and this is also in collaboration, basically led by people that, in DESC, in the strong lensing transient effort that we're really now ramping up. And one part that I want to highlight is we also, in the final steps towards getting a memorandum of understanding with the Euclid in regards of sharing watch lists there, basically targets the known strong lensing where we can cross match. I think this is going to be a very exciting thing in the early stages of LSST. Just a heads up, from simulation, we expect that about 50 multiply imaged supernovae will be in the data. It doesn't mean that we can find them all, but something we may be sensitive, and this is per year. So this is very exciting. Next step. So here just a bit more also with QR codes of really gearing up that for us on the strong lensing side, really new area of big data, hundreds, thousands, tens of thousands of lenses. On both on the static side and on the transient side, we are having data challenges with simulated data, very highly enhanced data, some of them using HSC, for example, in terms of light curves, in terms of images. And you see here the people leading those. The QR codes leads you to the website where you can participate in those. These are really ongoing and should also bring us step by step towards the the challenge and excitements that we get with LSST. Next. Here, okay, this is very brief, where can you find us? We have a website, reach out with the Slack channel Strong Lensing, and if you want to join in any of the teams that's been formed, please reach out to any of us, propose new projects, get involved in what's been done on the transient side, and also a shout out to people that are actually in person. So if you're in person, go and chat with folks. I think Phil Marshall, Anuprita, Shenmin Vu, and maybe some other people that should also raise their hands now in the audience to get in touch with.
Thank you, Simon. Next, we'll hear from the Transients and Variable Science Committee, but given the rapidly changing nature of the transient sky, I will also have to update the slides again. Hopefully that's fixed it. Igor, would you take this way?
Thank you, Gautam, and I will assure you it's worth it, this refresh of the page. You will see at the end. Hi, everyone. My name is Igor Andreoni. I'm speaking on behalf of the two co-chairs of TVS, so Sarah Bonito, who I believe is online, and myself. TVS is a large collaboration and rapidly growing. I think in the last 3 months, we onboarded probably more than 40 new members. So big thank you to the onboarding committee. I hope everyone will feel welcome within TVS. And in fact, with these slides that I really like to show is just a way to say, we really want to be, as a collaboration, the home for your science. And I hope you can find a home for your science in TVS as a whole and in all the subgroups, where you can contribute, you can ask for help, you can collaborate. And this will be crucial now that the data start flowing in. Let me point out, if you manage to go in the schedule to see the presentation, there is a link, TVS Highlights 2025. This is something we're doing every year. We present a slide deck where most groups in TVS will add what's new, what's some highlight they would like to share. So please go check them out. Well, some include obviously galactic science, variable transient sources, eruptive sources. A lot of incredible work has been done to that extent in the last year, as well as in the past. Some additional quick highlights. The fast transient subgroup has been refreshed, reactivated with new metrics that Shar, Christine, and others are working on. That will be even more informative for doing this science towards the decision, the finalization of the survey strategy. Other groups, such as the Tidal Disruption Event subgroup, has also restarted bi-weekly calls, really pulling members of many different collaboration and the community worldwide interested in this science. There's been a lot of supernova work, also including machine learning classification, and also TVS has task forces and some subgroups particularly dedicated to improving technology. And obviously that links directly to the science we're planning to do and we are doing. Those include, for example, searching for anomalies, doing accurate photometry in crowded fields, working on synergy with other ground and space-based telescopes. There's a lot of work done for software, putting all we have, all we can produce together, find the needs that we need to fulfill. And also we will have a dedicated task force for large language models coming very soon. A couple more things that we'd like to highlight. We have data now, so people are having fun with them, digging in. There are a couple of papers led by Jim Freeburn and Easy Dong that are coming on archive tonight. So please check them out. These, to the best of my knowledge, we present the first samples of transients discovered for the first time in Rubin data. And also additional work has been done, for example, by cross-matching existing data set with the new data made available as part of DP1. We like organizing meeting, like everyone. I think probably one of the largest of the last year was the one hosted in Rio de Janeiro. And I promise we also did science. Don't be fooled by the beautiful food, sceneries, and social activities that were organized. And I will prove that to you, by the way. For example, there was plenty of discussion about how we can further improve the upcoming target of opportunity program for Ruby. One idea that was proposed there, originally brought forward by Anais Moller, was to ask for the science validation survey to be extended so that more templates would be available for image subtraction in the region of the sky where the LIGO and Virgo detectors are most sensitive. And that resulted in that extra squared-ish patch of sky indicated by an arrow here in the figure. So to that extent, I want to stress that despite multi-messenger, other type of science that needs the observations, in general, the design and then the activation of this program is truly a multi-collaboration effort. Everyone is contributing, TVS, desk, solar system, and all the other collaborations. And also, I truly want to extend my thank you to the Rubin team for putting the work and for listening to the community. They actually had people coding in all the recommendations from the community. They listened to feedback. They modified the survey to try accommodate it as much as possible. So we're very grateful for that. And the last bit, which is what justified the refresh, was that, was it yesterday? Time is flying. Yeah, it feels so long. Only yesterday, there was the first activation of the Target of Opportunity program with Rubin. One of the people I would like to do a big shout out for is Sean McBride, here in the larger picture on Zoom. The people on Zoom there were planning and activating the program as they were speaking. And what you see on the left here is the probability map of these binary black hole mergers that we decided to follow up. The darker regions are where the probability is the highest, and the green circles represent the Rubin pointings. And so if you can notice is how well they overlap with each other, which means there will not be blank places of sky that Rubin will miss out. We'll have a very complete data set as part of this follow-up. So I will stop here and thank you all for your attention.
And last but not least, we'll hear from Ashley Villar, who should be online for the Information and Statistics Science Collaboration.
I am
Ashley.
online. Can you hear me?
Yes, we can.
Okay, excellent. Oh, impossible to follow up a GW trigger from TVS. Okay, so yeah, I'm excited to tell you a bit about this somewhat abnormal or unusual science collaboration that I'm very lucky to co-chair with Francois Lanous, which focuses on informatics and statistics or algorithmic work that we can do with LSST. This year has been focused by and large on restructuring and understanding where we best fit into the community. We've recently had a major restructure, and we now have in addition to the co-chairs, a wonderful group of members for our executive council that provide incredible amount of life and breath into it. I list them here because they're incredibly available on the LSST Slack, in addition to our ISSC channel, just through private messages. They're absolutely, in their own right, all experts on data analysis as well, as are the other 100 members of the collaboration. So I want to point out that in the last calendar year, we had our very first collaboration meeting at the Center for Astrophysics, which is highlighted here, where we brought together members of the ISSC in addition to representatives from the many other science collaborations. Can you do next slide, Gotham? Thank you. Right now, ISSC elections for co-chair is actively happening. So this is also my final presentation as co-chair, and Francois will also be cycling off. So we have very new, fresh faces as the data starts to roll in. And last year, we've really focused on setting up some of our structures. So we have a fully revamped membership process. We've moved to Google Groups, like it sounds other people have. And we have a newly set up publication policy. It's very easy to join us on Slack or in that highlighted link there. You can very quickly join the collaboration and get involved. Can you go to the next slide? I do want to highlight, oh, maybe I don't have it here. I want to highlight that the major goal here, there is not a scientific pillar that we are surrounding. Instead, very much our goal is to aid in achieving science for all science collaborations. So we're deeply interested in meaningful collaborations where we can leverage expertise from both astronomers, but also data scientists and engineers that are within our science collaboration. I want to highlight one of the more successful interest groups that we have are the anomaly detection groups, which specifically focus on the question of how do you find anomalies in real time in images and time series, etc., within LSST. Next slide. Yep. So if anyone wants to have some sort of collaboration, especially a data sprint, some sort of challenge, etc., please just reach out. We are very easy to find on Slack. Thank you.
Thank you. So we're at the end. Melissa, we have some time for questions for the chairs. Yeah, so if anybody has any questions for any of the SC chairs, please find a microphone. Or if you're online, free to use the raise hand feature.
This is Michael Strauss. This is a question for Igor. What in the coverage of the gravitational wave event, did you show us what is planned to be observed or what has already been observed? And the obvious next question is, when are we going to hear about results from that?
I think Gotham, you can also take this question. My take is that that's real. So we switched to that phase now. These are the actual pointings where the telescope observed. I think UGI. URI, it changed. URI, that's great. I mean, that's will give enough room for us to get colors, and also we will have synergistic data set with the dark energy camera. So this will be a quite spectacular follow-up all in all. And regarding when we will see the data, that's actually I would love to hear that answer. Can I put someone from the project on the spot? The eye roll was amazing, Eric. Thank you.
Hi, it's Eric Cullum. We're looking at the data. There's no templates here. It's very custom hand-holding processing. The weather is terrible on the summit, so we just have the single epoch. I would say stay tuned, but don't expect anything super fast.
Thanks.
Yeah, Tony,
okay, Tony Tyson. So we heard from Igor the term anomaly detection, and I'm sort of curious how many science collaborations here could also do that kind of work. I didn't hear it, but maybe somebody could raise their hands.
I guess maybe I can take this because I have some sense of what's going on across a few of them. ISSC, like Ashley mentioned, has an anomaly detection group. TVS has an anomaly detection group. DESC has a machine learning group, which has many of the same people and has a couple of projects on anomaly detection. I'm also reasonably confident the solar system, the strong lensing folks are effectively treating many of the strong lens system finding as anomalies in some sense. They're supernova, but there are multiple supernova in very close proximity. For example, if you're looking for multiply lensed transients. And so there's a few different efforts. I'm sure there are efforts in solar system and other groups. Of course, 3i Atlas itself is an anomaly in some sense. And so I do think the community is aware of this effort. That isn't saying there is more that can be done. And of course, the NSF created these two AI institutes in the past year, Cosmic AI and Sky, to concentrate on some of these tasks. So we're not quite there yet. but I'm very optimistic about what will happen.
Yeah, I'll mention briefly, we're also doing it in the AGN science collaboration to identify extreme AGNs as well as, AGN flares and such.
And changing look agent. Yeah, thank you so much, Neil. There is an anomaly detection session tomorrow at Madeira, I think, in the afternoon. I'm reasonably confident about that much, at least. Any last questions for any of our SC chairs? If not, far be it from my place to keep you from the rest of the session. Okay, well, if we don't have any other questions, let's thank all of our science collaboration chairs again.